let's finish the decision tree in this question. So we found out the expected value of not giving an internship to be 0.6. We did that in the first video. Now what we're doing is to calculate the expected value of giving the internship, and the expected value of giving the internship, so let's write it over here, the expected value of actually giving that internship, well, it takes into account the fact that it could be a talented player and it could be a not talented player, and for each case we have a possible outcome. If he's talented, we expect 1.9 million in return. If he's not talented, we would lose $500,000 for paying for the internship only. But what's the probability of those two scenarios? Well, we can take them from here, because we know the probability of having a talented player, that's 0.5, and the probability of having a not talented player is also 0.5. So the expected value that we're calculating is going to take those two things into account. 0.5 times 1.9 plus 0.5 multiplied with minus 0.5. And if we work out the math over here, I'm going to write it above because there's literally no more space. So if we work out the math over here, that would be an expected value of 0.7, so 700,000 euros. And what do we notice is that the expected value of paying for that internship is higher than the expected value of not paying for the internship. 0.7 is higher than 0.6. So it makes more sense for us to invest in the internship, because although we invest the 500,000 euros, the information of knowing whether he's talented or not is gonna make us is going to help us make a better decision. If we can make a better decision, we have a higher chance of having a higher return from the player, because if we find out that he's talented, we're going to invest in him, we're going to train him. If not, we're not going to offer him the contract, so we're going to save our money from not losing it any further. So this information is valuable for us to make a better decision, and that was the whole point of this question, is that in some cases, paying for information might be worth it. It might help us have a higher chance of success, a higher chance of a better decision. That's the whole intuition behind decision tree. We have conditional probabilities. We have a probability that depends on an information. And that's how we do it. We go from the beginning to the end. So we go backwards. We had step 1 to find out the probabilities, step 2 to define the payoffs, step 3 to find out the conditional probabilities, and then we find out in step 4 the expected values of the contracts in this case, and in step 5 we found out the expected value of the internship itself, whether we do it or we don't do it. And based on that, we make the decision what's more worth to us. And that's it. Hope this makes sense, and we are done.